why KL divergence of Q from P is not equal to KL divergence of P from Q. When you learned about KL divergence, you would have learned that it measures the expected logarithmic difference between two probability distributions. Here we are taking P and Q as two probability distributions. Then you can have this doubt that if it is anyway finding the difference between this distribution and this distribution, then how is it possible that KL, if you're taking of Q from P, how is this not equal to the KL of P from Q? Keep in mind, this means Q from P and this one is P from Q. Okay, that means P is the true distribution, Q is the estimated distribution, and you are trying to find KL divergence of Q from P. That is what this means. This is a very common doubt that you know P is a distribution, you know Q is also a distribution. In first case, you are finding how Q is different from P. Second case, you are finding how P is different from Q. Then why are these differences not the same? How is it possible that these are having two different values? So this is what we are going to understand in this particular lecture. Why is it that these two things are not equal? First point you have to understand is KL divergence, it is directional. The direction matters whether you are finding Q from P or P from Q. And the reason direction matters is that you are taking this expectation with respect to one particular distribution. When I say KL divergence of Q from P, I am finding the expected logarithmic difference between P and Q, but this expected difference means I am taking expectation of the difference. This expectation is taken with respect to P in this case, and expectation is taken with respect to Q in this case. This is the main point. It really matters that based on which distribution are you taking expectation. When you are taking the expectation of this difference with respect to P, you will get one value, and with respect to Q, you will get another value. Still, I know you will be unclear of the concept behind this. Mathematically, I told it, the explanation. Let's try to understand the concept clearly here. Let us say P is my true distribution. This is my true distribution. Using Q, I am trying to approximate P. So this is what I am trying to do. I have a true distribution which is called as P, and I am going to build a distribution Q which is supposed to approximate P. This is what I am going to do. Then when I say KL divergence of Q from P, what I mean is emphasizing where P is having larger probability, that is those areas where P is having larger probability. How badly does Q underpredict where data actually occurs? This is how you can understand KL divergence of Q from P. That means wherever P is having the mass, considering those areas, how badly is Q underpredicting? So you are not much concerned of those areas where P is not having mass. Wherever P is present, in those areas is Q able to identify P correctly. This is what you're mainly focusing on. But when I say KL divergence of P from Q, when this is the case, then it gets the other way around. Instead of the emphasis that is given on P, this time this condition is same. Still I am saying P is my true distribution, Q is my approximate distribution. Even if I keep this condition same, still when I take KL divergence of P from Q, this one, then it means emphasizing on Q. Previously we were emphasizing on P. This time emphasizing on those areas where Q has larger probability. Using those areas, you are seeing how much probability mass does Q waste on those areas where P is not even occurring. So this is the difference in perspective. In the first case, KL Q from P, You are checking wherever mass of P is present, whether Q is able to predict correctly, or in other words, how Q is under predicting or how badly Q is under predicting those areas where P is having mass. Instead, when I came to KL divergence of P from Q, this time I'm emphasizing on Q, and what I'm saying is wherever Q is having mass, among those areas, how much mass is wasted by Q by investing in those areas where P is not having mass. So this is the main difference. Conceptually, this is the difference. One more thing we'll do. We'll mathematically see how is it possible that these are different, and what is the scenario at which these can be equal. What are the conditions under which KL divergence can be equal? Okay, let us understand it mathematically. While looking into the mathematical side, you already know the formula that we use for KL divergence. That is, if it is KL of Q from P, this can be found as sum over all the x P of x into log of P of x by Q of x. So this thing I'm not explaining again because we had a complete detailed lecture on KL divergence. Though we specifically explained how this formula came up, what is the logic behind that, and all those things. Here we are going to find out why this is not equal to KL of P from Q. Okay. What we'll do is, let us try to understand when the difference of KL of Q from P with KL of P from Q becomes 0. That will give you an idea. Okay. If I take KL divergence of Q from P minus KL divergence of P from Q, if I do this, I will get sum over all the x P of x log P of x by Q of x minus sum over all the x Q of x into log Q of x by P of x. This is what I get. If I try to solve this, what I'll do is I'll take the common terms outside. So sum over all the x log P of x by Q of x. This I can make common, but the problem is here it is log P of x by Q of x, and here it is log Q of x by P of x. So if I want to take inverse of that, what happens? This can be rewritten as log P of x by Q of x whole raised to minus 1. This is a way of writing, another way of writing this. This minus 1, if I take forward, it becomes minus of this. So instead of having this term here, if I convert this minus to plus, what happens? Then both these will be log P of x by Q of x. So if I do that, then I'll get sigma x P of x log P of x by Q of x plus sum over all x Q of x into log P of x by Q of x. Now what do I have? I have this term common. Log P of x by Q of x is common. So what I'll do is I'll take sum over all the x. This term is now common, so I can take it outside. I'll say P of x plus Q of x into this one I'm taking commonly outside. It will become log P of x by Q of x. Here I know one thing. P of x and Q of x, these two are probabilities. Now think, when can this term become 0? That is only when the KL divergence of Q from P and P from Q, they will be equal. If they have to be equal, some of them, difference of them should be 0. So whenever this term becomes 0, that is when both of those will become equal. Now think about this. When can it become 0? If this and these are probabilities, then both of those will take values from 0 to 1. That means if I take sum of two probabilities, there is no way I can get 0. The only possibility is both the probabilities become 0. Otherwise, considering that there are some positive probability, Both these can never be 0. It's just not possible. So I leave this term. This term I'm not going to think about because I know I can't make it 0. Next term is this log p of x by q of x. If I can make this 0, then also my KL difference between KL divergences will be 0. Here I have an option. What is the option? I know log 1 is equal to 0. That means p of x by q of x, this should be equal to 1. When will it be equal to 1? If p of x by q of x, if this is equal to 1, that means p of x is equal to q of x. So whenever both these distributions are exactly same, both are the same distribution, then only KL divergence of q from p will be same as KL divergence of p from q. So this is the mathematical explanation. One more thing before we conclude the lecture. Okay, one thing. How can you understand this term log p of x by q of x? You can understand this as let us say surprise or the information gain. Information gain that you are seeing when you discover that one particular event that has occurred and you were expecting it. But the point here is your expectation is based on Q, which is your new distribution or the approximate distribution, but you found out that actually the points did come from P. Then how much is the surprise factor or the information gain that you got? That is what you can understand from this particular term log P of x by Q of x. Then one more thing we can discuss here, that is what major difference would mathematically come in the final value of KL divergence if I am taking KL Q from P or KL P from Q. Okay, this let us discuss. This will be interesting. So what we'll do is, let us understand what difference will it majorly make between KL Q from P and P from Q if I'm having different scenarios. I already explained you that KL Q from P, this sees wherever mass of P is present, whether Q is able to correctly predict. That also means if my P of x is greater than 0, if some mass of P is present, then it is expected that Q should be able to cover it. So if there is a situation where P of x is greater than 0, but my Q of x is equal to 0, that means my approximate distribution failed to identify one area where I actually have mass in P, then this will give a very large scale divergence. This will say I am having a large loss here and my KL divergence will shoot up. But if it is the other scenario, that is if my P of x equal to 0 at some point or very less at some point and Q of x, my approximate distribution says there is some mass here, this case won't be penalized like the previous one because here I am taking with respect to P. So it is important that whichever areas P is having some mass, that should be covered by Q. This is the most important part. But there may be areas where P is not having mass, but Q is unwantedly showing some mass there. That doesn't matter much. That is not a matter if you are taking KL of Q from P, this particular value. But if you take the other value, KL of P from Q, it will differ. That is, that if you have KL divergence of Q from P, then let us say you are having Q as a graph. So Q is, let us say, having multiple peaks, or sorry, P is having multiple peaks, something like this. Then in this case, when you are taking KL of Q from P, what Q will do is Q will cover both these peaks. But it is possible that Q covers a lot more area. It may be way more divergent, but Q will make sure that both these peaks are covered because otherwise this KL divergence is going to shoot up. But let us say for the same purpose, when you were approximating with Q, you used KL divergence of P from Q wrongly. Instead of using this, you use this. If it is a use case of this, that is you actually wanted to cover all the areas of P, but you wrongly used KL of P from Q, then what happens? Let us understand this. If you use this, This time what happens is expectation is taken with respect to Q, which means it is more important that wherever Q is having mass, your original distribution P should also have mass there. So maybe what your model will do is it will simply try to approximate one peak and it will say, hey, I covered this area, and if you cross verify with the actual distribution which is P, it is also covering this area, which means I am making correct approximation. So this is where you will go wrong if it is actually a case where you should take KLQ from P, but what you did is you took KL of P from Q. This is the situation. Or just to understand, we'll just see one more scenario. Let us say you are observing a rainbow. There is a rainbow and you observe this rainbow. So in this case, if you consider this case, KL of Q from P, and if P is the rainbow, let us say P is the actual incident where the rainbow is seen, and Q is your approximation or what you have built in your mind from this side. You saw P, which is the actual event. Then what you did is you reconstructed that in your mind, which is called as Q, and you are explaining this Q to your friend. This time, when you are explaining, you have to explain everything that was there in the rainbow, and it may happen that you constructed few additional stuffs. You saw something in the rainbow, you explained everything. Along with that, you explained a bit more additional stuffs which were actually not there. Still, it will be okay to do that if you are considering KL of Q from P. But the other case, KL of P from Q, then what happens? This time in your explanation Q, some part of this is there. The whole rainbow's part is there, not there. Only some part is there, but whatever you are explaining is correct. Everything that you are explaining, you have seen it, but you did not explain the rainbow completely. You only explained one part which you noted, and this part you explained to your friend. This is the case of KL P from Q. This is the main difference. I just want you to understand. P is the actual rainbow. In first case of KL Q from P, what you did is you explained the whole rainbow along with few additional stuff that you created in your mind. The other case, KL of P from Q, in this case, you saw the rainbow, you did not add any additional information, you did not create anything, but while explaining, you did not explain the whole rainbow. You just explained one part of it. Okay. So this is one way of understanding how it works. That's why I explained this way. That is it. This is the reason why KL of Q from P is not same as KL of P from Q.